The elimination method for solving a system of linear equations is a different method than the substitution method for ending up with an equation with a single variable. But that's the point. It's just another way of getting an equation with just x or just y. Now this one is set up to work right away really well for the elimination method. If I add both equations together, then I get 8x plus 0y equals 16. And now I have an equation I can easily solve, and I know that x is 2. How do I solve for y? I pick either of the original equations and plug 2 in for x. And then I solve for y. So the final answer will be 2, -7. If I were to graph the two lines, this would be the intersection point. This time, if we add the equations right away, we won't get rid of the x's or the y's. So we need to do a little more work on this one. We notice that if we multiply -3x by 2, it will perfectly match up with the -6x. They'll be the same thing. However, I don't want them to be the same sign. I want them to be opposite sign so that when I add them, they add up to 0. So if I multiply both sides of the second equation by -2, then my system of equations becomes this. Notice that the first equation did not change. Now, when I add the equations together, the x's go away. Now, on the last problem, the x's also went away, and there's nothing magical about going after the x's. That was just dumb luck. Half the time, it's the y's. When I add these together, I get 9y. When I add these together, I get 45. Dividing both sides by 9, I get y equals 5. And now I'm ready to solve for x. So I'll pick one of the original equations. I'll pick the second one, just for kicks and giggles. So I'll replace the y in that equation with what I know y equals. And I will now solve for x. And so the solution is going to be -9, 5. And that's how these are done. So you have to first determine what you're going to multiply by and to which equation, so that you are able to eliminate one of the variables. Once you have multiplied by the proper thing, it's just like the preceding topic. What do we do if there are fractions in there? Well, we do the same thing we always do when there are fractions. Get rid of them. So I will multiply the first equation by its least common denominator, which would be 6. So this gives one, when I multiply the 6 through to each term, I'll get x minus 2y equals negative 36. And when I multiply, well, what is the least common denominator for the second equation? Well, the smallest number that 4 and 5 divide into is 20. So I will multiply both sides by 20. And this will give 5x plus 12y equals 40. Now I'm ready to tackle this the same way I did the other problems. I could multiply the first equation by negative 5. That would end up giving me a negative 5x so that the x's would cancel. Or I could multiply the first equation by 6. That would give me negative 12y. When I add the y's would cancel. I think I'll do that. So, rewriting the system of equations after multiplying by 6, I get this. And now I can add the equations together. And that gives me 11x equals negative 176 and then x equals negative 16. Now I'm ready to determine what y is. So I go back and I pick an equation. I think I'll pick that one right there. I'm picking that one because I know that when I multiply the 1/4 by negative 16, I will lose that fraction and make the problem slightly easier. So I plug the negative 16 in for x, and I solve for y. I'll multiply both sides by 5/3 so that on the left, the 5 and the 3 will cancel. And on the right, I'm left with that. And I get 10. So final answer is negative 16/10. That is the intersection point for the two lines. Solve for y in both of these equations and graph their lines, and you will find that that really is the intersection point. Do that on the calculator every time. On this one, it's all about slope and things like that. So we need to determine if there is just, if there's no solution at all, in other words, if the lines don't intersect, or if they intersect in exactly one place, like normal, or if they are parallel and just never do intersect. And there are, oh, wait a minute, sorry. First one was parallel because they don't intersect. This one here, where it has infinitely many solutions, means that they're the same line, okay? So if they have no solution, they don't intersect, so they're parallel. Here, they intersect one time, which is normal. And here, they're the same line, which is why they have infinitely many solutions. Every point on one line will be a point on the other, and therefore a solution. So to determine what the answer will be, we need to solve for y so we can look at the slopes and y-intercepts. So in the first equation, if I subtract 4x, I get this. And the other one, if I get y by itself, I get this. And I can see in this example that the slopes are not the same, so they're not parallel. So the first answer is not going to be right. And they're not the same line, so because the slopes are different and the y-intercepts are different, we'd have to have everything to be a perfect match in order for them to be the same line. So that's out. So they must intersect in exactly one place. So we need to determine what that is. Well, let's do elimination method. It's ready to go right now. If I add the equations together, I get 2y equals 0 because those cancel and those cancel. Dividing by 2, y is 0. So what would x equal? I'll just take the first equation and replace y with 0. And dividing by 4, x is -1. So the intersection point would be -1, 0, which would also happen to be the x-intercept. Now let's do the other. Solving for y in the second equation, since the first is already done, we get y equals 3x minus plus 3. The second, or the first equation was y equals 3x minus 3. So the slopes are equal. So they're either going to be the exact same line or they're going to be parallel. So I know that they don't have one solution. That just doesn't make sense at this point. Now the y-intercepts are different. So instead of one line being there and the other line being right on top of it, the second line will be shifted down a bit because of that y-intercept difference. Therefore, since the slopes are the same, y-intercepts are different, they're going to be parallel and therefore no solution. Now, if, for example, this had been a plus sign right here, then the equations would have been identical and the answer would have been infinitely many solutions.